The title of this lesson is Analyzing Proportional Relationships. In this lesson activity, we're going to focus on proportional relationships in terms of graphs. Think about what you already know about graphing lines. How might we know if a relation on a graph is directly proportional? Think about it. If the graph data, the xy coordinates, are directly proportional, we will see a straight line that passes through the origin, which is coordinate 0, 0. So let's look at some data on this graph. Is there a proportional relationship? We plotted 2 points that fall on the line, and we have 1 and 15 and 2 and 30. So is 1 over 15, which is a way to write a relation, equal to 2 over 30? Well, 1/15 is equal to 2/30, so there is a proportional relationship. And as you can see, the line will pass through the origin of 0, 0. The graph showed distance and time. How do we know if the distance traveled is directly proportional to the time? Well, another way we can look at it is we can make a table of points that fall on the line, and we're going to look at all the x-coordinates, and between each x-coordinate there's a difference of 1, and between each y-coordinate there's a difference of 15. It's also interesting to note that the unit rate, can be found by using the formula for slope. The slope is the unit rate. So we have y2 minus y1 over x2 minus x1. That's the formula for slope. We'll take points. 30 minus 15 are the y-coordinates. 2 minus 1 as x-coordinates. And we get that the unit rate is 15 miles per hour. So at 15 miles per hour, we can go back to our graph. We would expect that for 8 hours, the distance would be 8 times 15, or 120 miles. And when you draw a line up from 8 and over to the y-axis, you see that indeed it is 120 miles. Does this graph show a relation that is proportional? What you see is a line that's plotted on this graph, but it doesn't appear to pass through the origin 0, 0, does it? That would have been my first thought too. Well, if we extend the line, because remember a line extends in both directions infinitely, we can see that it passes through 0, 0. So that would indicate that there is a proportional relationship. And once again, if there is a proportional relationship, the slope would give us the unit rate. And the unit rate in this case would be how much is one hamburger. So again, we're going to use our formula for slope. And we'll plot 2 points that fall on the line. And when we take the change of y over the change of x, we find that each burger, or one burger, would be about 38 cents. It's 0.375, but we would round it to 38 cents. That's what it would actually cost. And if you look at where the point is, where 1 crosses the y-axis, we see that it clearly is at 37.5, or 0.375, which is 38 cents. Okay, well that ends this very brief video introducing analyzing proportional relationships. from graph data. Enjoy the activity.